The best looking visual effects always include some sort of moving animation within their main body, whether that be fire, lightning, water, or even portals. Today we'll create a material which will provide you with the power to create these types of moving animations for your Niagara VFX. Let's get into the action. First, we'll create a new material by right-clicking in the content browser, selecting material and naming it something like m_add_scrolling Niagara. Then we'll double-click it to open up the material editor. As we want our material to be applied onto Niagara particles, we'll set its shading model to be unlit, its blending mode to additive, and add the nodes we need to apply a texture to a Niagara particle, whilst allowing us to dynamically set the color of this texture directly from Niagara. We'll promote our texture sample node to a parameter, naming it main texture, and then in the parameters panel, set its default value to the Niagara debug texture. If you can't see this texture, select the settings icon and make sure you have the show engine content option ticked. Let's also set our preview pane to display a plane so that we can see exactly what's going on with our material. In order to animate our texture, we need to be able to control how its UV coordinates get mapped. We can do this using a text coord node. If you hold the Ctrl and Alt keys whilst hovering over this node, you can see that it states that it outputs the UV coordinates in the form of a 2D vector, U being the horizontal and V being the vertical coordinates of our texture. Press A and left click in the material graph to create an add node, and then attach this node into the UV pin of our main texture. Now in order to move our texture coordinates around, we'll need to use the time node, which outputs the value of the time that has elapsed since the game has begun. If we drag this node into the B pin of our add node, you can see that our material is animating, albeit not in a very controlled manner. If we wanted to do something simple, like spring our texture, we could add a sine or cosine node before we add this time value to our texture coordinates. But instead, we use this time node to create a distortion effect, which will let us animate our texture by using a separate noise texture to offset its UV coordinates over time. To do this, press the S button twice in the material graph to create two scalar parameters, naming these distortion U speed and distortion V speed, U for horizontal and V for vertical. Then we drag both of these nodes into an append node, combining them into a single 2D vector. Then we multiply this newly created vector by the time node and add the output of this to our texture's coordinates. As you can see, if we set our U speed to 0.5 in the parameters panel, our texture moves horizontally and to the left. Then if we change this to -0.5, we can see it moving to the right. The same would happen vertically by altering the V speed. We'll set the default U speed to 0 and V to 0.2. In order to distort our main texture using noise, let's add another texture node by holding T and left clicking in the material graph. Then right click this texture, promote it to a parameter, name it distortion texture, and set its default value to be some noise texture. I'm using this noise texture I created from this great website. You can get the exact one I'm using from the link in the description. Next, we'll connect our node to the UV pin of this distortion texture, and in the toolbar, selecting live update and enabling real-time nodes. As you can see, our noise texture is moving as expected. But how do we use this to influence our main texture? We could use the append node to combine our distortion texture's RNG channels into a 2D vector, and then attaching this to our main texture's UV coordinates. However, you'll notice that this distorts our texture way too much. In fact, so much that we pretty much almost only see our distortion noise texture. This tells us that we need to create a way to control the amount of distortion which we apply to our main texture. If you know your materials, then you're thinking that we need to use a linear interpolation node, and you'd be correct. Let's delete the append node and create the slurp node by holding the L key and left clicking in the material graph. What this node does is output a mix between its A and B values according to its alpha value, which can range between 0 and 1. For example, if the alpha value is 0, it will only output the value that comes from the A node, and if the alpha value is 1, then it will only output the value in the B node, and anything in between will output a mix of the A and B nodes. Press this drop down arrow to see the values of our lerp node in real time. Then let's use this by setting our texture coordinates, which can also be thought of as no distortion at all, as the A value, and the R channel of our distortion texture, which can be thought of as maximum distortion, into the B value. Now let's create a new parameter by pressing S in the material graph, naming it distortion amount, and attaching it to the lerp node's alpha pin, then connecting our lerp node into the UV pin of our main texture. But as you can see, nothing has changed in our preview panel. However, if we change this distortion amount in the parameters panel to something like 0.05, you can clearly see that our main texture is being distorted by our noise texture. However, we have a slight issue. If we switch our preview panel to be a cylinder, you'll notice that our distortion effect has resulted in the seam. This happens because we're moving our texture's UVs when distorting it, which moves it out of alignment. To solve this, we need to add our distortion texture to the texture coordinates before we pass them into the lerp node. This way it can recenter our UVs. Now that we've created our distortion effect, let's add another feature to our material which will allow us to dissolve our effect based off another noise texture, empowering us to create more unique animations. To do this, let's copy the scrolling system we created for our distortion texture and move it down here, renaming our speed parameters to dissolve USpeed and dissolve VSpeed, and our texture to dissolve texture. But how do we use this to influence our main texture? Let's multiply this dissolve texture with our main texture and connect it to the multiply node before we attach it to the emissive color pin. As you can see, our output has extra noise and is not as bright as it was before. Now let's add a power node to control the intensity of this dissolve effect. We'll also create a scalar parameter, we'll name it dissolve amount, and attach this to our power's exponent, and give it a default value of 2. Now we can play around with this, as well as the horizontal and vertical speeds to change the way in which this dissolves our texture. To demonstrate another useful feature which we will add to our effect, we'll create a new empty Niagara system, and in it add a simple sprite burst emitter. We'll set its loop duration to 10, disable its scale color module, and in the sprite renderer set its material to be the new material we just created. As things stand, if we wanted to change our material's parameters, we'd need to create a material instance, then change the values of these in the details panel. However, there's a much better way, and it's really a lifesaver when using Niagara. Let's go back to our material editor. Right-click and search for Dynamic Parameter. With this node, we have access to 4 float parameters, which we can name whatever we want and do with whatever we want. Let's name our first parameter Distortion Amount and second Dissolve Amount, then set their default values to 0.1 and 2. We'll then connect these nodes into the alpha pin of our distortion lerp node and the exponent pin of our dissolve power node, exactly where our previous parameters were. Now let's go back to our Niagara system and add a dynamic material parameter module to our particle update stage. As you can see in the selection panel, we now have access to these parameters directly from our Niagara system. So let's set our distortion amount to be a float from a curve. If we let this play, we can see in our preview panel that over the particle's lifetime, our dissolve value changes based on our graph. I hope this material empowers you to create beautiful effects for your games. Join our Discord to ask any questions about this system and showcase your creations. If you want to support our channel, please consider checking out our Patreon. Please like, subscribe, tell somebody you love them, and we'll see you in the next one.